So taking these one at a time, a million threads incrementing a million elements does give the correct answer because in this case there's a unique element for every thread, so there's no conflict. So even though we didn't make these atomic increments, we're still safe. A million threads atomically incrementing a million elements is of course also safe, so you'll also get the correct answer. A million threads incrementing 100 elements is the same example we saw before, and as we saw, that will give the wrong answer unless we use atomics. So the next one is not correct, the fourth one is correct. And finally, 10 million threads atomically incrementing 100 elements will still be the correct answer. So all but one of these give you the correct answer. Okay, so the more interesting question is how long do each of these options take? The fastest, perhaps counterintuitively, is going to be option 3, a million threads writing into 100 elements. And the next fastest will be option 1, a million threads writing into a million elements. On my laptop, these two operations take around 3.2 milliseconds and 3.4 milliseconds, respectively. Of course, it's not a very useful option since it doesn't give the correct answer, but it's still interesting to look at what's going on. So the reason why this is slightly faster is that you have your million threads all trying to write to the same 100 elements. Well, those 100 elements occupy a very small fraction of memory, and they're all going to fit into a cache line or two on this system. Whereas a million elements is large enough that it's not going to fit in cache. You're actually going to have to touch more of the DRAM where global memory is stored. For the same reason, a million threads writing into 100 elements atomically is going to be slightly faster than a million threads writing into a million elements. So the next fastest is option 4. The next fastest after that is option 2. And in my system again, these took 3.6 and 3.8 milliseconds, which means that the slowest of all options is the one where 10 million threads write into 100 elements. This is actually 36 milliseconds, so it takes approximately 10 times as long to complete. Not surprisingly, there's about 10 times as much going on. So you might play around with this code for a little bit. For example, see what happens to the time as you go to even more threads writing into even fewer elements. The big lesson here is that atomic memory operations come with a cost.